All right, let's get into it. Today, we're pulling back the curtain on how some of the smartest applications out there are actually built with Python. We're going to take a journey, starting with the rock-solid backend foundation and going all the way up to the really cool MLOps pipelines that, bring AI to life.
So, you've got this brilliant idea for an AI feature, right? But how do you actually go from just a single line of Python code to a complete interactive system that people can actually rely on? I mean, how is it really built? That's the big question we're diving into. And the very first piece of that puzzle is building the stage where our AI is going to perform.
Okay, Section 1, building the digital stage. It's all about crafting the foundation for these intelligent applications. Every great performance needs a solid stage, right? Well, before our AI model can even think about making its debut, we have to build that stage. And that stage is the backend infrastructure. This is the absolute bedrock where our app is going to live, run, and hopefully scale.
Now, it is absolutely crucial to understand the difference between these two. So let's stick with our analogy. Think of the backend as the physical stage itself, the lighting rig, the sound system, all the structural stuff that supports the show. MLOps, on the other hand, that's the entire production crew. It's the director, the stagehands, the whole process from rehearsals to opening night. It's their job to make sure the AI, our star actor, delivers a flawless performance every single time.
So how do we actually build this stage? Well, it really boils down to 4 key layers. First up, we code the API. This is how everything talks to each other, using awesome Python frameworks like FastAPI or Django. Next, we have to get our database ready. We'll provision something really solid like Postgres, probably on a managed service. Then comes the really cool part, defining our entire cloud setup as code, basically a master blueprint. And finally, we wrap the whole thing up in a container using something like Docker, so it can run absolutely anywhere. You put those 4 layers together, and what you get is a system that's tough, repeatable, and totally ready to scale. Let's zoom in a bit on the database. This is basically the system's long-term memory. And look, we're not just spitting up any old database. We're using a managed service like AWS RDS. And you might ask, why bother? Well, because it handles all the painful stuff for us. I'm talking automated backups so you don't lose data, read replicas so you can handle a ton of traffic without slowing down, and high availability failover so the show keeps going even if something breaks. And this really highlights why SQL optimization is so important. Because honestly, without it, even the most powerful hardware will just grind to a halt. Okay, this right here, this is one of the most important ideas in all of modern infrastructure. Seriously, instead of, manually clicking around in a cloud console hoping you don't forget a step, we write code. We use a tool like Terraform to define literally everything, our servers, our databases, our networks, the whole shebang. What that blueprint gives us is the power to build, tear down, and rebuild our entire environment flawlessly every single time. It is the absolute key to consistency and automation. All right, our stage is built. It's solid. Now, it's time to get our AI actor ready for the spotlight. Welcome to Section 2, the MLOps assembly line. This is all about automating the entire journey, from a pile of raw data to a polished, professional, production-ready machine learning model. So, what is MLOps really? Look, it's not just one tool you can buy. It's a whole culture, a set of practices. The idea is to take all the good stuff from DevOps, automation, collaboration, constant improvement, and apply it to the very unique and tricky world of machine learning. And here's the bottom line. This is what takes AI from being a cool science experiment in a notebook to something that's actually scalable and reliable out in the real world. This timeline pretty much shows you the whole assembly line from start to finish. Of course, it all begins with data, which we need to store somewhere safe and scalable, like AWS S3. Then, as we start building our model, we track everything using tools like MLflow or weights and biases. I mean, every single experiment, what worked, what bombed. Next, we use something like SageMaker to automate retraining, so our model is constantly getting smarter with new data. And finally, you have CI/CD workflows, which are just automated pipelines that take our tested, validated model and push it out into the world for everyone to use. Okay, so you've got all these moving parts. How on earth do you make sure everything happens in the right order at the right time? That's exactly where an orchestrator like ZenML comes into play. Just think of ZenML as the factory manager. It's their job to watch over the entire assembly line, making sure data gets from station A to station B correctly, and that the whole process is perfectly repeatable and as bug-free as possible. The model is built, it's been tested, it's packaged up. You know what that means? It's opening nice.
So, Section 3 is all about running the show live. We're talking deployment, monitoring, and making sure the performance in production is top-notch. It's not enough to just launch it. We have to keep a super close eye on it to make sure it's always delivering a star-quality performance.
Remember that Docker container we made earlier? Well, now we have to actually run it. Probably hundreds or thousands of copies of it. On AWS, you basically have two main choices. There's ECS, which is the simple AWS native, it just works option. Then there's EKS, which gives you the full power and flexibility of Kubernetes, which is pretty much the industry standard. The choice really comes down to a classic trade-off. Do you want simplicity or do you want ultimate power and flexibility?
Pushing out a new version of your AI can be, well, terrifying. What if there's a bug you missed? That's why we have these safe deployment strategies. With a blue-green deployment, you literally build a complete, identical new version, the green one, right next to the old blue one. Once you're sure it's good, you just flip a switch, and all the traffic goes to the new one instantly. A rolling update is a bit more gradual. You slowly replace the old application instances with new ones, one by one. It might be a little slower, but it's a great way to minimize risk and disruption.
Okay, once we're live, the job is not done. We have to watch everything. And our monitoring toolkit has a few different layers. At the base level, you've got AWS CloudWatch for general system health, CPU usage, memory, the basics. Then you have AWS X-Ray, which is awesome for digging into performance issues by tracing exactly what happens during a user's request. But when you're dealing with large language models, you need a whole new set of specialized tools to watch for things like latency, data drift, and especially AI hallucinations, where the model just makes stuff up. We'll get to that in a sec.
All right, so we've built a really solid system, but now it's time for a major upgrade. This is Section 4, the new AI brain. We're about to supercharge our model by swapping out the standard AI brain for something way more powerful. Large language models, or LLMs, combined with a whole new kind of memory. One of the biggest game changers for working with LLMs is a technique called RAG, or Retrieval Augmented Generation. And honestly, it's genius because it's so simple. Here's how it works. When a user asks a question, we don't just blindly send it to the LLM. Nope. First, we do a super fast search in a special kind of database to find relevant documents or info. Then, we take that info and stuff it into the prompt right alongside the user's original question. The result? The LLM now has the exact context it needs to give a way more accurate and factual answer. So what is this special database I'm talking about? It's called a vector database. You've got players like Pinecone, Weaviate, even extensions like pgvector. The key thing to understand is that they don't search for keywords. They search for meaning. This is called semantic search, and it's the absolute magic behind RAG. So, for example, it understands that if you ask about vehicle fuel efficiency, you're probably interested in documents about car mileage. The words are totally different, but the concept is the same. That's what it's searching for.
All right, now let's talk about the big, scary challenge with LLMs, hallucination. This is when the model just confidently makes stuff up. It'll state something that's factually wrong or completely nonsensical, but it'll sound totally sure of itself. This is a massive problem when you're trying to build trust with your users. Now, techniques like RAG definitely help reduce hallucinations, but you have to be vigilant. Constant monitoring for these kinds of outputs is non-negotiable for any serious production-grade AI.
Okay, let's recap. We've built the stage, we've prepared our AI actor, we've given it a supercharged new brain. So for our final act, we're going to give it the ability to think, to plan, and to act all on its own. This is Section 5, Orchestrating Intelligent Agents. We're moving into the realm of building autonomous systems. Now to build these autonomous agents, you need a whole new toolkit. LangChain is kind of the classic starting point for chaining an LLM together with other tools like an API or a calculator. But when the problems get really complex, you need something more. That's where LangGraph comes in. It lets you build these intricate workflows with loops and decision points so the agent can actually reason its way through a multi-step problem. And then you have crazy cool stuff like LiveKit, which lets you give these agents eyes and ears, the ability to interact with us in real time using audio and video. So after this entire journey, you can see how it all comes together. It really is like an orchestra. The backend we built from scratch, that's our perfect, sturdy stage. Our MLOps pipeline, that's the professional crew working tirelessly behind the curtain to make sure everything is perfect. And these amazing new agent frameworks like LangChain, well, that's the conductor, leading our brilliant AI performer and guiding it to execute incredibly complex and powerful tasks.
And that brings us to one last, really interesting question to leave you with. We have the stage, the crew, the performer, and the conductor. But as these AI orchestras get more and more complex, more autonomous, you have to wonder, who's going to be the composer? Who or what is going to write the music they perform. It's definitely something to think about as this incredible technology keeps evolving. Thanks for joining me.